Hello everybody. Core Pure 1 is tomorrow. I literally cannot believe Core Pure 1 is tomorrow. And every time there's an exam, a big exam, so the Core Pures, any of the maths exams, I'm always going to be doing one of these live streams. And I am so pleased we've got like already 350 people here. I want to know, to begin with, how are you guys feeling right now? So I'm going to start a poll. Has it worked? Yep, I've started a poll. There are 4 options. I want to know how you're feeling right now. Are you feeling calm and ready? Terrified? What was my other options? Same as normal. And then what else have we got? Tired. Okay, interesting. So if you do come along to, if you haven't voted, it's just a really nice way for me to check like how many people have actually come across this as well. Because I imagine for most of you, this is your first, I'm going to turn this light off actually. I imagine for most of you, this is your first exam. This is your first proper exam. And this first exam is quite a tiring, not tiring, quite an intense first thing to go through. And I'll talk a little bit more during this session about what I want you to kind of be thinking about after this first exam or even before this first exam, because there's a lot of psychology that kind of goes into this sort of stuff. Anyway, I'm going to talk to you about what we're going to do in today's session. I'm going to try and keep an eye on the chat that we've got here as well. We've got Breezy. Breezy is one of my moderators, so he's just here to kind of keep an eye if there's anything I've missed. He'll be able to tell me about what's going on with this kind of stuff as well. And in this session, I am going through some questions that you will have never seen before, because these have been written by a very talented student who is in year 13 at the moment. His name is Gavin Aurora, and he is studying maths, further maths, physics. I think it's just maths, further maths and physics, but maybe there's something else. Maybe Gavin will tell me that in the chat as well. And I've been working with Gavin over the last few weeks now because he's a very talented question writer, and he has been coming up with some really amazing contexts for some different questions. And what I'm going to be doing is using his questions. I obviously co-edited them with him. I've sort of said, oh, can we change this? Can we try and make this thing look like this? Because I think that has been a really good thing. I wanted to try and make sure for this that we had a really fresh set of questions that would be useful. Now, there are a few things I wanted to very quickly tell you about that I think might be useful for you. If you are in a last minute pinch and you want to do some revision on either Core Pure 1 or Core Pure 2, my sessions that I ran over the Easter holidays, my Aiming for A-star sessions, are 50% off. So they are £15 each, and you can get the recording of that immediately, and you can start working on that this evening if that's something that you wanted to do, but I wouldn't recommend you staying up too late. And that's for all of the further math sessions. They're all 50% off, and that's all linked in the description. And then the second thing is on Saturday, I am running a session that is called my in-between Core Pure 1 and Core Pure 2 session. And this in-between session is nearly selling out. It's £15 for 3 hours on Saturday morning, where we will focus on just the stuff that has not come up from the first Core Pure paper. I'm actually going to be going to the exam hall tomorrow to sit the paper. I'm going to just leave it blank, so if anything, I'll be dragging the grade boundaries down, even though one person can't do that anyway. So I will have, out of anybody that your teachers or anyone else you see on YouTube, I would have seen every question, and I will be able to think, is this the kind of thing that could come up in the next paper? And that will be my goal, really, to try and make that Saturday session covering some questions that haven't come up and try and give you some tips that will help for that. If the live sessions do sell out at that £15 price point, you can just buy the recording of it, which will then come out on Saturday afternoon. You've still got then Sunday, Monday, Tuesday, Wednesday to be able to use that. And as well as it being that 3 hour session, there is an additional video of me going through some other questions as well. Okay, so the last thing I'm going to say about is there is something else that is linked in my description too. There are 2 students, there's a boy called Oscar and a boy called Sebastian. Great name. If you don't know, it's my name too. I am not sponsored by them. I would never do that kind of stuff anyway. But what they've done is they've created an app that is called Locked In, and it's about trying to make revising in exam season a bit more social, in the sense of kind of sharing where you're at with things and a way of like holding yourself and some of your friends accountable. They're probably in the chat right now if they want to say anything about it. Totally not sponsored at all. I just really like, if any student reaches out to me and says, hey, I'm working on this project, I like to try and sort of support people as much as possible, which is kind of how I've ended up working with Gavin. Gavin reached out to me and I thought, let's try and do this kind of stuff. So if you're interested in this app that's called Locked In, you want to say like, actually, that'd be quite a nice thing to have with my friends during exam season, it's right at the bottom of the video description that we've got, okay? Yeah, I've just come back from Istanbul. We will get going with the maths very quickly. I've just seen Mohammed Mahdi has said, did I have a good trip? I did. I really had an amazing time in Istanbul. You may have seen I did a little video of some stuff in Turkish as well. But you're not here to hear about how my little holiday was in Istanbul. Although I said the word break, that's triggered me because obviously I broke my leg. I'm hoping I will get my boot off on Friday. So I've got to do the exam on Thursday. Again, I'm just going to leave it blank so I get a full experience of it. I'm going to do the exam in the boot, and then after that, I hope it's going to be freed up. So we've got 653 people here right now, which is crazy. And I think we haven't had everybody vote. I'd love to see how people are feeling. Okay, so I've mentioned some of those things. I'll probably part way through take a little break and mention a couple of these things as well. I'm going to keep an eye on some stuff in the chat. But we're going to start going through some of these questions that are kind of like fresh questions that we've got here. This is my day before Core Pure 1 live stream 2026. And these questions have been written by the very talented A-level maths and further maths student Gavin Aurora, who reached out to me via email. And they've obviously been co-edited with me that we've got here. And we've tried to, together, come up with some questions that feel fresh, feel a bit different. However, to start off with, we're going to start off with a pretty classic question because I didn't want to go in too heavy for the first question of the day before Core Pure 1. I didn't want to go in too heavy. I wanted something a bit classic, but we'll be seeing that there's some other questions that are coming up for this that we've got, okay? So first question. The complex number z equals x plus iy satisfies this equation that we've got here, where k is a real constant. Given that this equation has exactly one root or one solution, determine the value of k. So this is going to be a nice little warm-up for us that we've got here. So we have our z conjugate plus k. I'm just going to write this down for part A. So we have our z conjugate plus k. I've got a bit of a cold, by the way, so apologies if I keep sniffing. I think I must have caught a cold in the plane. Is equal to 6i plus 2. So we know that z is x plus iy, and we know that our z conjugate is obviously x minus iy. So I'm literally just going to go in and start substituting some of this stuff that we've got in for this, okay? So we're going to have our z conjugate, oh my god, my voice is going to be so sore by the end of this, plus k divided by z, which is my x plus iy, is equal to 6i plus 2. Now, I'm going to do a bit of expanding and stuff, but what other things do you expect me to do at this stage that we've got here? What other things might you expect me to do as maybe like a first step for this kind of thing that we have got? What might be like the first thing we'd try? Yeah, realising the denominator is probably a good one to try, but I actually think just cross multiplying is probably going to be a bit safer here. You've just got less manipulation that is required. So I'm probably going to just take this part and I'm just going to put it up here. Okay, that's probably what I'm going to do in this question. So when I expand these brackets, we obviously know that that's going to be an x squared plus y squared plus k. And then on the right hand side, we have the 6i plus 2 multiplied by the x plus iy. So we have x squared plus y squared plus k. When I expand these brackets, I have a 6xi plus 2x. I then have a 2, I've got these two and these two. I'm then going to have the, why am I not able to expand these brackets? What on earth is going on with my brain? I'm going to do the 2 times this and then these two, so the y parts. So I have the 2yi. And then for the last part, that will be a minus 6y that we've got here. Once you've got to this stage, I want to have a look up in the chat and see what you think I'm going to need to do with the right-hand side and left-hand side. Obviously, I'm going to collect together the real parts. So I have my 2x minus 6y, and then I have my 6x plus 2y that we've got here. What am I going to be doing for this next part? Could somebody 99 compare the coefficients for the real and imaginary parts? So there's nothing imaginary on the left hand side here. So I know that the 6x plus 2y, this is from the imaginary parts, must be equal to 0. So the 2y must be minus 6x, so the y is minus 3x. And then for the real parts, well, the left hand side is entirely real, so x squared plus y squared plus k must be equal to the 2x minus 6y. And then obviously we're going to do some simultaneous equations that we've got here. So I'm going to take this y equals minus 3x and I'll substitute it into these places that we've got here. So subbing that in, we will get x squared plus, well, I can square that straight away and I know that's going to be a 9x squared plus k equals 2x. Then I've got minus 6 multiplied by minus 3x. Okay, that's just going to be 18x that we've got. So I have the 2x plus 18x. So this is 10x squared minus 20x plus k equals 0 that we've got here. What do you think we need to do at this stage that we've got, given that one of the key things in this question was that it has exactly one root for this, that it's got exactly one root? Oh my god, I'm going to get sniffing so much. I'm so sorry. That's one of the most annoying noises. That is brilliant. I just love seeing in the chat just like a flood of these correct answers that we've got. You can see why this is kind of a warm-up, right? So if there is only going to be, was it one solution? Yeah, one solution. We're going to say that b squared minus 4ac is going to be equal to 0. So b squared, that's minus 20 squared, minus 4 times a times by c. So 400 minus 40k is 0. Pretty much you can see it's going to be 400 equals 40k, and so k is equal to 10. Nice little warm-up question that we've got here. K is equal to 10. And then it says, hence show that z is equal to 1 minus 3i. Show that z is equal to 1 minus 3i. Well, because this is like the x part and this is the y part, I think I just need to find out what x and y are equal to now that I know that k is equal to 10. So I probably can continue and solve this equation for the next part. So for part B, our equation was 10x squared minus 20x plus k is equal to 0. And I know that k is equal to 10. So that's 10x squared minus 20x plus 10 is equal to 0. I can divide everything by 10. So I get this. And then if I factorize this, you could use the equation solver, whatever you want to do for this thing. I'm going to say that my x minus 1 squared is equal to 0. So that must mean that x is equal to 1. And do you remember we said something earlier on that's highlighted in yellow that's up here? That's y is equal to minus 3x. So y is equal to minus 3. Hence, z is equal to x minus 3i that we've got. So nice question there, pretty straightforward. We are now going to have a look at this next part. It says that the cubic equation x cubed plus px squared plus qx plus r, where p, q, and r are real constants, has roots alpha, beta, and gamma. Given that alpha is z, beta is z conjugate, of course, we know that they come in conjugate pairs like this, so it had to be like this, and that gamma is equal to 4. Determine the values of p, q, and r. So we have that f of x is x cubed plus px squared plus qx plus r. We know that alpha is this, beta is the conjugate, and gamma is equal to 4 for this. So people are telling us exactly all these things that are going on. We can do the sum of the roots and all of this. Now, a little tip for you, because again, I don't just want this to be going through questions. I want this to try and be like, what could you do in the exam for this? Just to remember how these things go. I know that the sum of the roots is minus b over a. The sum of the pairs is going to be c over a. And then all of them multiplied together is minus d over a. So we know that these parts are all associated, these parts are all associated, and these parts are all associated, and it goes minus, plus, minus. In this case, though, we can see that a is just equal to 1. So I can say that p is, or minus p, the sum of the roots is minus p over a. So minus p is the sum of the roots. We can see that q is just going to be the sum of the pairs, and r is going to be, or minus r, because there's the minus here, is just going to be the alpha, beta, and gamma all multiplied together. So minus p is all of these things here added together, which we can see. You don't have to write it all out. You can see what that's going to be. There's the 1 minus 3i plus the 1 plus 3i plus 4. The 3i's are going to cancel and we get 4, 5, 6. So that means that p is minus 6. Now q is the pairs. I probably will for the pairs write them out. So I'll have the 1 minus 3i, the 1 plus 3i, plus the 1 minus 3i times by 4, and the 1 plus 3i times by 4. You can put this on the calculator if you want to, however you want to go about doing this. I am going to say I have the 1 times 1, and then the minus 3i times plus 3i. That's going to give me 10. Check the calculator if you want to. I will get a 4 from this part and a minus 12i, but that will cancel with this plus 12i. We know it's going to be real parts. So we just get 10 plus 4 plus 4. which is 18. And then for the last one, minus r is all of them multiplied together. So we know that those first two multiplied by 10. So minus r is 40. And so r is minus 40 that we've got. Okay? There is a last part to this question. And it says, using the relationships between roots and coefficients, determine the exact value of alpha squared plus beta squared plus gamma squared. Now, I know this is going to be really hard for you to type, but if you use A, B, and C, and you can use a capital S for summing, I just want to know, does people remember like what this should be for this? Yeah, people are saying it's hailing. The weather has been crazy today, absolutely crazy. So people have got some answers for this, and I've seen some people have suggested it. Student S3Q came up with this. So the sum of the singles minus 2 the sum of the doubles. Absolutely love it. There's some great stuff coming through in the chat here. So it's going to be the sum of the singles minus 2 the sum of the doubles. Probably something that's worth memorizing that we've got here. I don't know if this is going to be that bad. So alpha squared plus beta squared plus gamma squared is the sum of the singles minus the 2 of the doubles. We did the sum of the singles. We did them up here. It was 6. Oh, it wasn't the sum of the singles though, was it? It's the sum of the singles all squared. I think people had probably written that, didn't they? Yeah, they did. They did. I just wasn't being very good at reading what people were saying. This is where having a live chat in an exam would be disastrous, because you might misread something. So we're going to have our 6 squared minus 2. The sum of the pairs is here, which is 18. So minus 2 times 18. So it's 36 minus 36. And so our answer for that part there is 0. Okay. We are nearly at 700 people, and we've had 860 votes for this already. This is amazing. Okay, this is really, really good. Wow. Okay, a couple of things I was going to mention is I think this is just a warm-up question. I asked Gavin to do some easy ones, and Gavin did some very hard ones, and I said, well, we're going to have to do a mixture of these bits. You can check some of these, couldn't you? You could actually, in theory, you could solve the equation. You could take all of the roots and add them and square them. So you could do this squared plus this squared plus this squared, and you could check that it adds up to 0, but it did say something specific in the question. It says using the relationships between roots and coefficients. So we had to use this method. Of course, you could just do alpha squared beta squared plus gamma squared, but we wouldn't normally have it in that kind of way where we actually knew what all 3 of the roots are. So we kind of forced ourselves down this particular route. Okay, now people have been talking a lot about proof by induction and saying like, is it possible to have weird kind of proof by induction questions? And I don't know if this is the kind of thing they could ask about. This is actually in the textbook, but I thought this was a really good opportunity to see a proof by induction question in an unusual context and just to think to ourselves, okay, well, let's just work through this and kind of stay calm with what's going on for this. So we're going to try and do a proof by induction to prove de Moivre's theorem that we've got here, just to look at what happens if we see proof by induction coming up in an unusual kind of context for this. So you guys know exactly the stages that we should be doing for these kinds of questions. We're going to start off to show that it's true for n equals 1. Show true for n equals 1. Well, when n is equal to 1, we know that z is just equal to cos theta plus I sine theta. And we also know that z to the power of 1 is the cos of 1 theta plus I sine of 1 theta, which is just cos theta plus I sine theta. Hence it's true. A bit hard to show that one, but hence it is true for n equals 1. Next step. What is the next step? Because you're going to find me often saying, hey, what do you guys think in the chat? So that I can have an opportunity to have a bit of a drink with stuff. You could put it into exponential form, but I'm actually going to just keep it in trig. I think it makes sense to keep this one in trig, and you'll see what happens for this. Yeah, good. We're going to assume the true. It's assuming that it's true for n equals k. So let's assume true for n equals k. In other words, z to the power of k is cos k theta plus I sine k theta. And now what we're going to do is prove or show that it's true for n equals k plus 1. So we're trying to do z to the power of k plus 1. How am I going to find z to the power of k plus 1? What do you think I need to do to go from zk to zk plus 1 for this kind of thing? Oh my goodness, I am hoping I'm going to feel better tomorrow. Good, we're going to split it as z to the power of k times by z. So we're doing z to the power of k times by z. Well, z to the power of k is cos k theta. I probably don't need this bracket, right? So I'm probably just going to write it as cos k theta plus I sine k theta multiplied by z, which is cos theta plus I sine theta. So we're going to do some double bracket expansion with this. We're going to have the coses times, which is cos k theta cos theta. I'll then have the cos times the I sine theta. So that is going to be I. Let me give a bit of space to this, actually. That is going to be plus I cos k theta sine theta plus I sine k theta cos theta. Let's buy myself even more space and just kind of put this across here. And then our last part, well, we have the sines times by each other, but there's an I with both of them. So the I times I is going to give us a -1. So it will be minus sine k theta sine theta that we've got here. Now, I think some people, I knew I could just look at the chat and see what was happening that we've got. And then people are saying, great, there's going to be the exponential form for this. If you want to use the exponential form, you absolutely can do as well. If you want to do it with the exponential, you do what you want to do. This was the way I approached this. So if you look at these things that we've got here, they can be rewritten, right? That is cos, sine, sine. So this is actually the same as the cos of k theta plus theta. That's the yellow part that we've got. And then for the blue part that's here and here, if you recognize the formula for the addition formula, this is the I sine of k theta plus theta. So the only thing that needs to be done now is write this as cos of k plus 1 theta plus I sine of k plus 1 theta. So we've proven that it's true. That z to the power of k plus 1, it's the same thing as this expression, but wherever there's a k, there is now a k plus 1. So I'm going to write, hence, as it was true for n equals 1, and when assumed true for n equals k, it was true for n equals k plus 1, it is true for all positive integers n. It is true for all positive integers n. Just tell me in the chat, what are the contexts that we need to be aware of where we could do proof by induction? This is an unusual context. I don't think this would come up, but it's just interesting to see that we've got here. Bachira is right. I normally just write conclusion in capital letters, but I thought, seeing as I've got 750 people here, I should actually write it properly. So we've got matrices is one of them, where you're going to do powers of 1. It kind of follows a similar pattern to this, doesn't it, of doing that? We have matrices, we have divisibility, we have series, we also have differentiation. Now, recurrence relations was in the spec. It's not clear to me if it is or isn't in the spec anymore. I tried to look at the specification today. I don't think it's actually there. So I think derivatives is something that can get asked about for this. Very, very, very interesting that we've got here. That was only part A, okay? This is where Gavin has, I think, been inspired by a previous question. The rest of these, he's gone and done some brand new kind of stuff. So this question is going to teach you, not teach you, but it's going to kind of show you some things about how to keep your work organized and not make silly mistakes, because this one is very demanding in terms of the algebraic demands for this. So we're going to use de Moivre's theorem to show that this thing here is true. For this type of question, again, it's really hard for you to type, but do you know how you get set up with these kinds of ones? Because there's two kinds of approaches for the de Moivre's question. But if we're trying to do this in terms of powers of cos, do you know what's the first thing that we need to do for this? Again, it's really, really hard to do here. Oh, thank you, Oscar. Yeah, I'll try and give you more shout outs for your app locked in other live streams as well, because I think what you've made is really good, and I like to support students as much as possible. Good, we're going to be doing the c plus is to the power of 6 stuff. So we know that if we do cos theta plus I sine theta to the power of 6, I know that that's going to be the same thing as cos 6 theta plus I sine 6 theta that we've got, okay? So what I'm going to work on is doing this part. But before I do this, I know loads of people have already used like the C and S. I highly, highly recommend just telling the examiner at the beginning, let's let C equal cos theta and let's let S equal sine theta. So what we're actually going to be doing is C plus IS to the power of 6. Please, when you write your S, make sure it looks different from a 5. I would probably do like a big 5 and a small s because it's so easy to get those things confused. And I'm just going to go out and do some binomial expansion for this, but we're pretty good at binomial, right? So we're going to have a c to the 6. The first coefficient is going to be a 6, then c to the 5, and then there will be an is. I take it a little bit slower. So for my next coefficient, it will be a 6 choose 2, which is going to be a 15 c to the 4 is squared. So using this little trick means you're going to be writing out far fewer things. If I do 6 choose 3, I then get 20c cubed is cubed. Then I'm going to have a 15, which will be c squared is to the power of 4. I knew I was going to run out of space. I thought, wow, look how much space I've left for myself, and it still wasn't enough. Then I'm going to have my 6c is to the 5. And then for my last part, I'll have my is to the power of 6, like this. And you just got to be really careful with kind of like subbing in and sort of expanding all of this stuff. So I'll have the c to the 6, which will then be for the next part. There will be 6i c to the 5s. You then have an I squared, which is going to be a negative. So that's minus 15c4s squared. You then have I cubed, which is going to be a negative I. So it's a minus 20i c cubed s cubed. And then you have I to the power of 4. So that's a minus 1 and a minus 1, which gives you a plus 1. So it's just going to be a plus 15 c squared s to the 4. We have a I to the power of 5, which is just going to be an I. So we get a 6i c s to the 5. And then for the last one, I to the power of 6, that's going to be a minus 1, a minus 1, and a minus 1. Minus 1 times minus 1 is plus 1. It's going to be a minus 1. It's going to be minus 6s to the 6. No, not 6. Just minus s to the 6. Let's see if that is correct. So I go real I minus 1 minus I real I minus 1. Okay, good. I'm happy with all of those things that we've got written. Now, I don't want to simplify this whole expression. What do I want from this thing that I've just highlighted in blue? Which of the parts of it am I actually interested in this question? Good. I only want the real parts. Remember, the real part is the only bits that I want in this question. So the real part will be this, 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 and this. It's very easy to make mistakes. Notice how I'm trying to go quite slowly and stay quite focused for this. So cos of 6 theta, the real part, is c to the 6 minus 15 c4, and then I have sine squared. Sine squared is 1 minus cos squared. I then have 15 cos squared sine to the power of 4. So this is sine squared. That's sine squared. I'm going to have to square that to get it to be the power of 4. That's quite a jump that we've got. And then for the last part, sine to the power of 6. Well, sine squared is 1 minus cos squared. So that needs to be cubed because of that last part that we've got. We need to go from it being sine squared to sine to the power of 6. Squaring to the power of 3 gives us to the power of 6 for this bit that we've got, okay? So we have c6 minus 15c4 plus 15c6. I personally would take this slowly, and I do 1 minus c squared all squared. That would be 1 minus 2c squared plus c to the 4. And then I can just do the binomial expansion on 1 minus c squared. I know the coefficient's going to go 1, 3, 3, 1. So it's going to be 1, 3, 3, 1. But that's going to be a negative. I think that seems good. I have, 1, then I have c squared, c to the 4, c to the 6, positive, negative, positive, negative. Every now and then I'm like looking at the chat and being like, have I made any mistakes for this stuff? So it's so important to keep your page organized and to keep your cool, because if you make any mistakes, it can get really, really stressful. And when I talk is when I make mistakes. So let's hope I haven't made any, but we'll soon find out, won't we? 15c to the 6 minus 1 plus 3c squared minus 3c to the 4 plus c to the 6. Obviously, we wouldn't be using highlighters in the exam, but we know that we're wanting to start with cos to the power of 6. So I'm hoping for 32 cos to the power of 6. So I have this one, this one, this one, and this one. Great, I do. I have 32 cos to the power of 6. Then for the next part, the powers of 4, I have minus 15, minus 30, minus 3. That's minus 48 cos to the power of 4. And then for the squareds, I have 15 plus 3, which is 18 cos squared. And then I have minus 1. So this is my cos 6 theta. Anything that you think I should do to just finish off for this question, or do you think it's fine here? Anything that you think we should do for this bit? I would never highlight my actual work in the exams, because when it gets scanned, it can sometimes block what's written underneath it. So just be a bit careful of that. Obviously, I need to write it back in the form that was required in the question. So cos 6 theta is 32 cos to the power of 6 theta minus 48 cos to the power of 4 theta plus 18 cos squared theta minus 1. So now we'll have a look at what part C is, and it says, hence find the 6 distinct solutions to this equation that we've got here, giving your answers to 3 decimal places. Now, what's the biggest difference between, if I very quickly highlight, what's the biggest difference between these two things that I've got written? There's a few things that are different, but there's probably 2 main things, and one of them is very obvious, which is that some of them are in terms of cos and the other one is in terms of x. But there's obviously something that's different, and people are telling me this in the chat as well, that we've got the minus 3 over 2 instead of the minus 1 that we've got. So our equation is 32x to the 6 minus 48x to the 4 plus 18x squared minus 3 over 2 equals 0. But instead of writing it as minus 3 over 2, I'm going to write it as minus 1 and then minus a half, so that I kind of split it in that form. And I'm also going to let x be equal to cos theta. Okay, I'm going to let x be equal to cos theta. If x was equal to cos theta, then I can simplify this entire section that I've got here as cos 6 theta. So that we get cos 6 theta minus 1/2 is equal to 0. So cos 6 theta is equal to 1/2. They haven't given us a range. They just said find all of the solutions for this. So because I've got to find all of the solutions, I need to come up with 6 of them, because I think there's going to be 6 solutions, because it is a, I don't even know how to say that. We'd have like a cubic, quartic, I don't know what it is for the next bit. So I'm going to come up with all of the solutions, and then I'll divide by 6. We should know this, but the inverse cos of 1/2 is pi over 3, right? Inverse cos of 1/2 is pi over 3, that's true. And then you do 2 pi minus that, it will be 5 pi over 3. But I'm going to keep going and find some of these other ones that we've got, okay? I'm now going to add the 2 pi onto both of them. So I'll do 2 pi onto this and 2 pi onto this. So 2 plus a third is going to be 7 pi over 3. 5 thirds plus 2 is 11 pi over 3. I'm now going to add 2 pi onto both of these. So 7 thirds plus 2, that's 13 pi over 3. And then 11 pi over 3 plus 2 pi is 17 pi over 3. So that's what 6 theta is equal to. But we don't want to find out what that is. We need to find out what x is. And x is cos theta. So I need to find out what the thetas are by dividing everything by 6. So we get this, that one, this one, this one, and this one. And then all we need to do is go into our calculator and substitute all 6 of these things into cos theta, because that was the substitution that we did, to find out what x is equal to. So I'm making sure I'm in radians mode, of course. and I'm going to be doing the cos of pi over 18, and I'm just going to keep going through and changing the different values. I think it wanted it to 3 decimal places. So for 3 decimal places, we have 0.985. That was with the first part. I'm now going to put in the 5. We then get 0.643. I'm now doing the 7 pi over 18. And we get 0.342. I'm now going to do the 11 pi over 18. And we have minus 0.342. I'm now going to do the 13 pi. I think you can predict what's going to happen here. We get minus 6.43. And then I'm going to do my last one, which is the 17 pi over 18, which is minus 0.985. So we have 1, 2, 3, 4, 5, 6 solutions, which is exactly what we were expecting for this kind of question. Now I have a question for you, right? Because this is trigonometry, what do you think would have happened if I found 2 more solutions and then found 2 more solutions and then found 2 more solutions? Would I be able to have 2 more solutions at the end? What do you think would have happened if we continued finding more solutions in these kinds of things? They're going to start repeating, okay? They're going to start repeating. So that's why they didn't give us in this question a range of values. If you have the CG50 or the CG100, I don't know if they can solve up to the 6th power. Let me see if they can. Polynomial. No, they can't. So you can't check it. However, you could check it by taking this equation, the left-hand side, putting it on the graphing part, and then finding out where all of those solutions are that you've got, and then see if it works, okay? So I'm going to just take a very quick pause for a second to remind you, if you like the way that I teach, okay, at the weekend on Saturday, I am doing this in between Core Pure 1 and Core Pure 2 session. I'm actually going to the exam. I'm doing the exam, but leaving it blank tomorrow. So whatever hasn't come up in Core Pure 1 for EdXL, I will be preparing a session on Saturday. It will be mostly from international papers. I may write a couple of bits of the questions myself, but because I've only got 1 day to prepare the session, it's not going to be completely fresh questions, but it won't be past paper questions, okay? Not from our specification. It's only £15 for 3 hours, plus you get a video of stuff that is coming after it as well. This always does sell out, but if you do get the recording for it, you get the recording later on Saturday, and then you will be able to kind of use it over those next few days as well. And if you're looking for some stuff to do tonight, I do have my Aiming for A-star sessions that took place in the Easter holidays for Core Pure 1, Core Pure 2, and options modules, which obviously you're not going to be doing tonight. All of those are 50% off, so they're £15 as well. And if you buy those immediately, you can just use that straight away, okay? And then the other thing is, I had mentioned this for a couple of people, students, if you're wanting to do some, like, hold yourself accountable with some revision, there's an app that a couple of students have designed called Locked In. Not sponsored at all, I just like to help people out as much as I can in these situations. Okay, so here is an interesting question. I loved this one when Gavin sent this through. It's a Matrices question, and it says that a nutritionist is monitoring the micronutrient levels of patient alpha measured in milligrams. Initially, the patient has 1,000 milligrams of iron, 1,500 milligrams of magnesium, and 2,500 milligrams of zinc. After 1 month of taking supplement A, the iron level increased by X%, the magnesium level increased by Y%, and the zinc level increased by Z%. The nutritionist also noted that the total combined increase across all 3 micronutrients was 155. The increase in magnesium was 35 milligrams less than the combined increase of iron and zinc, and the increase in magnesium was 40 milligrams more than the increase in iron. By forming and solving a 3x3 matrix, find the values of X, Y, and Z. So I really liked what Gavin had done when he designed this question, because he actually has said that we have an increase of X%. And originally he phrased it in a slightly more challenging way. And I asked him, I was like, no, let's try and make this like really crystal clear that X in this case is a percentage. It's not representing like a thing that you multiply by. So it looks like we're just looking at how much things have increased by, or how much things have changed. So if we have a look at iron to begin with, iron is X. It started at 1,000, and we want to find out how much it has increased by. It's increased by X%, which means we're going to multiply it by X over 100 for this part. Okay, it's going to be just multiplying by X over 100. The 1,000 divided by 100 is just going to be 10. So we just get 10X. In other words, it has got 10x is the amount that it's increased by. What have we got next? The magnesium. So for the magnesium was 1,500. That's gone up by y%. So y% is y over 100. 1,500 divided by 100 is 15y. And then for our last part, our zinc that we have is going to be, there was 2,500. This was when it was being monitored. It's going to increase by z%, which is the z over 100. So it is 25z that we've got here. So those three things are actually representing in milligrams how much they have increased by taking this particular supplement that we've got. So let's try and take these three parts here and write them as equations. The total combined increase across all three micronutrients was 155. So 10x plus 15y plus 25z is 155. The increase in magnesium was 35 milligrams less than the combined increase of iron and zinc. So the increase in magnesium, that's 15y, was 35 milligrams less than the combined of iron and zinc. So it's going to be the iron and zinc minus 35 for this part. Now I think I'm going to want to write that in a different form so that it looks exactly how you would expect it to be for like a matrix equation. So I'll take the 10x over here. I've still got the 15y. I'll take the 25z over, and we've got that is minus 35. So I've dealt with this one and this one. I'm now going to have a look at the last part, which is that the increase in magnesium was 40 milligrams more than the increase in iron. So the increase in magnesium, that's 15y, was 40 than the more of iron. So that's going to be the iron plus 40. But again, because I want this to be a matrix, I'm going to rewrite this. I'll subtract the x part. I will leave the y part. There's no z part. And that is equal to 40. So I've now got these three equations, this one, and this one. And I want to set this up in a matrix kind of form that we've got here. Someone said I made a mistake. Where did I make a mistake? Did I make a mistake? No one else was telling me I've made a mistake. So lost 8 marks and a 10 mark because I missed my... All right, someone else is talking about this. Okay, cool. So let's write this as a matrix. I think, if I get it off the highlighter there, we have the 10, the 15, and the 25, the minus 10, the 15, and the minus 25, the minus 10, the 15, and the 0. That is all getting multiplied by x, y, and z, and it gives me 155 minus 35 and 40. By the way, if you wrote this one in a different form as like 10x minus 15y, plus 25z equals 35. Obviously, that's completely the same thing because you've just rearranged things in a slightly different kind of way. So I wouldn't worry about that at all, okay? And then I'm going to do my x, y, z is equal to 10, 15, 25. Now, while I'm writing this out, do you think we need to write out what the inverse matrix is? Do you think we need to do that whole process to be able to get these marks? Is that something that you think is going to be required for us to get full marks for this type of question? Do we need to find out what that inverse matrix is? No, definitely. I don't even need to find this thing out. The examiner thinks now that I'm going to type that into the calculator. I'm not going to type that into the calculator. I hate typing matrices into the calculator. What do you think I'm going to type into the calculator? What am I going to type in? I don't want to type in matrices. Everyone hates typing in matrices. So I'm not going to be using matrices on the calculator. It's just such an annoying thing to type in. It didn't say find it. I'm going to use the simultaneous equation solver. They want us to use matrices. They'll never know. They'll think I've typed this in. I'm going to take this, this, and this. And I'm going to go to my simultaneous equation solver with 3 unknowns. So that's 10, 15, and 25, 155. Minus 10, 15, minus 25, and minus 35. Minus 10, 15, 0, and 40. Oh, very satisfying answers. Integers. What an absolute treat. That is telling me... I'll pretend that I did it though, right? I'll pretend it looks like a matrix. 2, 4, 3. So x is 2. Y is 4, Z is 3. Remember, these things are representing percentages. So it was a 2% increase in magnesium, zinc, whatever it was, in these 3 different supplements that we've got, 2 and 4 and 3%. So Patient beta, who has the same initial micronutrient levels as patient alpha, thinks that supplement A is too expensive and is looking for a cheaper alternative. The nutritionist recommends supplement B to patient beta, which only affects iron and magnesium. So there's a lot of reading in these questions, and I loved how Gavin has designed this because the reading is a challenging part. After 1 month of taking supplement B, the iron level increased by P% and the magnesium level by Q%. The nutritionist, also noted that the combined increase was 80. The increase in magnesium was 20 more than the increase in iron. This time it doesn't want us to do matrices. It says do an algebraic method, and it's only 2 marks for this. So it's a really similar part to before. So instead of it being X% and Y%, it's going to iron and magnesium. Iron and magnesium is this stuff. It's still going to be 10p and 15q instead. So it will be, for part B, 10p plus 15q. That's the increase in iron, and that's the increase in magnesium. It says that that is 80 milligrams. And then the increase in magnesium was 20 more than the increase in iron. So magnesium is Y, and this is iron. The increase in magnesium was 20 more than the increase in iron. So that's 10p plus 20. So it just says use an algebraic method. I just need to solve these equations simultaneously. So I'm going to take this, which is 15q, and just replace it in here. So I end up with 10p plus 20 is going to be 80. So 20p is 60, and so p is 3. And if p is 3, then 15q is equal to 10 times 3 plus 20. So that is what? 30 plus 20 is 50, and so q is 50 divided by 15, which is 10 over 3, or 3.3 recurring as a percentage. So let's see this last part. We found out what P and Q are. It now says the effectiveness of a supplement is determined by considering the average percentage increase it results in across the nutrient it affects. So not across all 3 of them, but just the 2 or 3 that it affects here. And this is where reading is incredibly important, okay? By using your answers to A and B, determine whether supplement A or supplement B is more effective. So for supplement A, we had that X was 2, Y was 4, and Z was 3. So I'll find the average, 2 plus 4 plus 3 divided by 3. So that's 9 over 3. So the average is 3%. For B, we have that P is 3 and Q is 10 over 3. So 3 plus 10 over 3 over 2 is 3.16% recurring. So I can say 3.16 is greater than 3. Hence, supplement B is more effective. Now, of course, you may want the supplement to affect all things, but when we read this question really carefully, it does just say which ones it affects. So that's why we got to this stage. Okay, I will be releasing a list of topics that we'll focus on after Core Pure 1. I will immediately, after the exam tomorrow, I'll make a quick video reacting to the paper and telling you what I've thought of this thing, okay? So, I need to go and get a tissue to blow my nose. I'll be 1 second. I swear, every time I go on an aeroplane, I always feel like I get a cold. Does anyone else have that? It's so annoying. It is so annoying. Yeah, if you want access to the questions I'm doing right now, it is linked in the description. And again, I know I've said it a couple of times. I'm going to do a special shout out and a thank you to Gavin. So you may have seen a question that uses this function before. It's actually quite a nice one, but it's an unusual one in this kind of question. We are doing polar coordinates. We're going to have a look at this one and try and remind ourselves of some of these key features that we've got. So, Figure 6 shows a sketch of part of the curve C with polar equation r equals 1 plus tan theta and theta is between 0 and pi over 2. The tangent to the curve at the point P is perpendicular to the initial line. Find the polar coordinates of the point P. Now, something I wanted to just point out about this question that I think is really interesting is it just kind of starts, the curve is here, but the pole is over here. It's quite unusual that it starts like this, and it kind of is because when theta is 0, r is equal to 1. So I know that this distance along the bottom here must just be that r is equal to 1 for this kind of thing. And we have that at P, the tangent is vertical. Can you tell me in the chat, what do we know if the tangent is vertical to it? Good. It's dx d theta is equal to 0. And I'm going to do a quick reminder of why this is true. We know that dy d theta, we know that the gradient dy by dx is dy by d theta divided by dx by d theta. If I want the gradient to be like this, that gradient is undefined. Things are undefined when we divide by 0. If the gradient was going to be like this, a flat gradient, that gradient is 0. We would want the top part to be equal to 0 instead. So we would say that dy d theta is equal to 0. So we know for this question, for part A, dx d theta is equal to 0. For part A, dx d theta is equal to 0. I'm not going to ask you in the chat. I know that you know x is r cos theta, and we know that r is equal to 1 plus tan theta. So x is 1 plus tan theta multiplied by cos theta. So that's cos theta plus tan theta cos theta. But you should know, right? Tan theta cos theta is going to simplify because we know tan theta is sine theta over cos theta. So they cancel. So all of that was just setting up what x was equal to. We're now going to say what dx d theta is. We're going to differentiate. Cos goes to minus sine. Sine goes to cos. And we know that dx d theta is equal to 0. So when it's equal to 0, we get that sine theta is equal to cos theta. I just put the sine theta on the other side. Dividing by cos theta, tan theta is 1. And so theta is pi over 4. Looks like it's pi over 4 as well, right? That kind of looks like 45 degrees. It's not accurately drawn, but I think that's what it looks like. So I'm quite happy with that as the 45 degrees. But it does say find the polar coordinates. Remember, for polar coordinates, it goes in the form r theta. So now I actually need to find out what r is equal to for this. So r is equal to 1 plus tan of pi over 4. Further maths, we know that tan of pi over 4 is 1. So it's 1 plus 1, which is 2. Hence, the coordinates of P are r and theta. Okay, we're definitely going to need an extra page for this. Then we have, I love this question because what Gavin has been able to do is just mix together some stuff to do with derivatives, and then for the next part, it's area. The point Q lies on the curve C. The region R is bounded by OP, OQ, and the curve as shown in figure 6. Fine, it's this region that I can see. Given that R equals 1 plus root 3 at the point Q, find the exact area of capital R, giving your answer in this form, where these are integers to be formed. Well, I think I now know that at this point, at P, I know that the angle is pi over 4. I think I need to know what the angle is at Q, because you've probably heard me talk about this in other sessions, right? You know how the area gets built up. I'm sure you can tell me in the chat, because actually, with this sore throat, I'm trying to drink as much water as I can here. Whoa, I've just seen we've had 1,410 votes. This is crazy. Yeah, good. They come out like rays of sunshine, don't they? They come out of rays like this. So that's why. I mean, this is a pretty simple one, right? It's obviously got to be that. I need to find out what the angle is at Q. I'll do it up here. No, I won't. So it's 1 plus root 3 is R, okay? It's 1 plus root 3. So let's find out what it is for Q. 1 plus root 3 is equal to 1 plus tan theta. This is at Q. So root 3 is tan theta. And so that must mean that theta is pi over 3. That's one of my big flexes, is to know the tan of pi over 3 and tan of pi over 6. So at Q, it is pi over 3. Stuff like this, annotating your diagram just kind of helps you sort of stay on track of it. Again, it's very hard for you to type this in the chat, but I hope you remember that the formula for the area is a half r squared d theta, and we're going between pi over 4 and pi over 3. So let's just dive in and see if we can figure out what we need to do for this type of integration. And this is where it gets further mathsy, right? This is where we need to think, do we know how to integrate all of these different kinds of functions that we've got? If you don't want it spoiled, don't look in the chat. I'm going to expand these brackets. So I get 1 plus 2 tan theta plus tan squared theta. And I need to integrate that with respect to theta. Okay. Any idea, this one that I've put the red loop, what I'm going to need to do for the red loop for this? And people are already telling me about the other stuff as well, which I think is amazing. Good. This red one is in the formula booklet. And for people that have taken my advice, 1 plus tan squared, we know what 1 plus tan squared is. It's sec squared. 1 plus tan squared, 1 plus tan squared theta is sec squared theta. And that's a good thing because I know how to integrate sec squared theta. I know that tan differentiates to sec squared theta. So we didn't kind of like rush into stuff too quickly, and we did use the formula booklet. I have got the formula booklet up here, but I know from the formula booklet the integral of tan x dx is ln sec x plus c. Okay, so we have 1/2 the integral from pi over 4 to pi over 3, 2 tan theta, 1 plus tan squared is sec squared theta, d theta. Now I can actually do the integration, so I'm not going to use the integration sign anymore, am I? This is going to be 2 ln sec theta. Tan goes to sec squared, so it's just going to be tan theta. And it is pi over 4 and pi over 3. Let's add in a blank page for this one. So let's do some substitution, but let's not go too fast with this. So we're going to do sec of pi over 3. I like to do little bits of working on the side of the page, right? I'm trying to work out what the sec of pi over 3 is. Well, I know that that's the reciprocal of cos of pi over 3. And I know that cos of pi over 3 is a half. So I know that 1 over a half is 2. So actually, when I sub in pi over 3 into sec theta, I get 2. You could do it on your calculator. I kind of don't like using the calculator. Tan of pi over 3, you probably would check that, right? But tan of pi over 3 is root 3. And then I'm going to do the same process for this sec of pi over 4. So sec of pi over 4 is 1 over cos of pi over 4. It's the reciprocal of 1 over root 2. So it's root 2. You do it however you want. I just am old school and I don't like to do tons of stuff like this on the calculator. So I'll be subtracting 2 ln root 2 plus tan of pi over 4. That's, I'm sure you all know tan of pi over 4, right? So we have 2 ln 2 plus root 3 minus 2 ln root 2 minus 1. And it looks like we're kind of getting to the stage that was required. Apart from in our answer, we only want there to be 1 ln that we've got for this. So is there anything that you think we can do to try and tidy up this line that we've got here? Is there anything that you think we can do with this? And again, I'm going to try and not feel... Yeah, I'm going to try and sort out the log stuff, okay? Let's do it here. Let's save a bit of time. That's 2 to the power of a half. So I can bring that a half down and times it by 2. A half times 2 is 1. So we have a half, 2 ln 2 plus root 3. It will just be minus ln 2 minus 1. So it's a half. 2 ln 2 minus ln 2 is ln 2 plus root 3 minus 1. And I think that means that our values of P, Q and R, P is 2, Q is 3, and R is -1. Freya, the link in the description has got the questions, okay? And then afterwards I'll put the annotated versions of it as well. So there's a bit of a summary there. Remind ourselves of the key features if a polar question comes up. It's to do with derivatives. If you're looking for something that has undefined, dx d theta is 0. If it's 0, dy d theta is equal to 0. And I'm probably just going to write down here as like a bit of a thing for us to remember if it comes up. The area is a half r squared d theta between alpha and beta. And the way I remember that is it's the same as the formula for the area of a sector that you have in normal maths as well. Now in this, I'm kind of just going through the questions quite quickly, right? I'm literally just answering the questions. But when I do this in between Corpio 1 and Corpio 2 session, that one, there's more teaching. There's more me explaining things. They're saying, how do we remember these things? What should we be doing? In the live streams, it's a bit more like, let's just do some questions together. So if there's any particular topics you want to, that you want to do like tonight, there is also my Aiming for A-star sessions, which are 50% off, £15 for like 3.5 hours, 4 hours of content. It's exam time, right? But we don't want to go up, I don't want you to stay up too late. It's important you don't stay up too late, okay? So, what did you think of this question? I think it's nice, right? We've done 4, we've got 3 more questions. Which ones, actually, I'd rather know what's been the favourite question so far. We've had the roots of polynomials. We've had the de Moivre's question, which is hard to say. We've had the matrices question. And we've also had the polar. I think Gavin has done a great job of writing these. Any particular favourite questions of these ones so far? Yeah, I liked the polar one too. The matrices was nice because he'd done it with this different thing of doing the percentages for that question, which I thought was really, really interesting. The kind of thing that could trip people up in the exam with this. Good, good, good. Good, I'm pleased people agree with me that Gavin has made some good questions. We've got some good ones to come though. What do we normally feel when we turn over a question and we see this much text? Every year I ask people this: when you see a question with this much text, what do you feel like? Like it's just classic. Everyone feels like, oh my god, I don't like this question. I don't like all of this wording that we've got. Now, I think, and I don't know what inspired Gavin with this, but there was a question in an exam paper a while ago that you may have seen. Do you remember the tennis question of a tennis ball that was flying over a tennis net and it actually was moving with like a quadratic? I think that Gavin has been a little bit inspired by this because we've got this kind of moving kind of stuff. Oh, Gavin, I'm pleased everyone's loving your questions as much as I am. I think that there's like a bit of an inspiration of this because this is kind of combining this question when we read through it. It's combining like position vectors and velocities and stuff, but it's still everything to do with vectors. Obviously, when we do vectors, we try and identify what's a line, what's a plane, what's a point, and then try and go from there for these kinds of things as well. So a helicopter is hovering at a fixed point, 100, 200, 1500. In this model, the origin O is on horizontal ground. The unit vectors I and j point due east and due north, respectively, and the unit vector k points vertically upwards. All coordinates and distances are given in meters. A skydiver jumps from the helicopter at t equals 0 seconds. For the first 10 seconds of the jump, her position is modelled by the line that we have here, between 0 and 10 for t. I'm just going to stop there for a second. This thing, what actually is this thing if it's next to time? I know it's the direction. I don't want you to tell me that it's the direction vector. I want you to think what this is actually representing in terms of like a real context. If you have something that's multiplying by time and we're trying to describe where someone is in this particular thing. So I love someone saying, yeah, it's describing, actually, let's be even really specific. Let's say this is really describing the velocity that we've got here. And so I'd like it if you can try and describe this. We can see how she is moving at this stage. She's moving a little bit to the right, a little bit east, a little bit north. Maybe there's some wind that means she's not falling directly downwards. She's kind of coming at an angle. And every second she is falling 50 meters. And it's implying that this is constant velocity. If we wanted to criticize this model, that's not going to be realistic, is it? We're not being asked to criticize the model here. But if we were, this would not be a constant velocity for this beginning bit, but it's just a model, okay? At time t equals 10 seconds, the skydiver opens her parachute. Her motion is now modelled by a second line R2. She now moves at I plus 4j minus 16k meters per second. The skydiver is modelled as a particle. The ground is modelled as a horizontal plane at z equals 0. The effect of air resistance is ignored. Find the vector equation of the line R2 in the form R equals A plus SD, where S is the time in seconds after the parachute is opened. So let's just think, what do you think the strategy should be if we're going to try and find out the vector line of the second stage of her journey? Because this is kind of crazy, right? Like, we've got 2 stages to this journey. It definitely feels like a mechanicsy kind of question. And Z has said this. I think Z was the first to say this, that we've got t is equal to 10. Find out the position vector at t equals 10 for this, okay? So let's do this. I'm going to try and do this all on this top page here. So when t equals 10, let's find out where our parachutist is. So there's the 100, the 200, and the 1500, plus 10 lots of 2, 5, and minus 50. So 100 plus 20 is 120. I don't even need my calculator. That's the real flex. 200 plus 50, 250. Didn't make a mistake. And then 1500 minus 500 is 1000. So now that's the position where she's at when she opens the parachute. So we're going to now say that the new equation of the line will be, she is at this position and she's going to be moving S lots of I 4j minus 16k. Now, I know the question hasn't asked this, but if we make a comparison between this thing that I'm going to highlight in blue and this thing that I'm going to highlight in green, why have they, which I'm going to try and zoom away so you can see it, why have the values changed? There's one value in particular that I'm interested that's changed. It's not asking us about this, but this is what I'm trying to do, go a bit deeper in these questions. What has changed? Why has it changed in the context of this question? The K part has changed. Good. And the east and north has changed. Maybe the wind has changed a bit because of this like parachute that's come up. She's slowed down, right? She's slowed down because previously she was hurtling towards the ground at 50 meters a second. Now it's slower at 16 meters per second. It's still pretty fast. She's probably going to hurt herself when she hits the floor, but whatever. It's not real life. We're not going to stress ourselves with it. So that was the equation. We're now going to do part B of the question, which says this. Find the time taken for the skydiver to reach the ground from the moment that she jumped from the helicopter. Okay, so if I need to find out when she reaches the ground, what do you think I need to do? I think if this is 1000, if I was going to write this as a single thing, when she reaches the ground, that's when z is equal to 0. So I know from R2, I want the 1000 minus 16s to be equal to 0. I want the 1000 minus 16s to be equal to 0. So 1000 divided by 16 is 1000 divided by 16 is 62.5. So S is equal to 62.5 seconds. But be careful, it does say find the time taken from the moment that she jumped from the helicopter. So the total time is 10 plus 62.5, which is 72.5 seconds. Okay? 72.5. Sorry, my camera was blocking that we've got there. Okay. Of course, there's more. A drone is hovering at 151,375.20 to capture footage for a skydiving documentary. The shortest distance, calculate the shortest distance between the drone and the skydiver's path, R2. Well, the drone is obviously a point and the skydiver's path is a line. We are being asked to find the shortest distance, therefore, between a point and a line. The point is 1, 5, 1, 3, 70 and 5, 20. And the line equation that we've got in the previous part, that was 120, 250, 1000. 120, 250, 1000. And I'm going to multiply by the s as well. So there's the 1s, the 4s, the 1s, the 4s, and the minus 16s. We have a line and a point. We're trying to find the shortest distance between them. Do you remember the method that you need to use? And if you haven't watched my Core Pure 1 vector chapter summary that is 1 hour long, I spent so long making that video. If you are stuck on vectors, it will just be such a good refresher. I really, really recommend going and have a look at this. So we've got to find the vector between the line and the point. Thank you, I can see lots of people telling me this. So I'm going to find this vector between these two things by subtracting. So I'm going to do this one, subtract this, to get a vector between them. So the vector between is that, subtract that, 120 minus 151. Why the weird things I do on my calculator. So it's minus 31 plus s. I'll do this, subtract this, 250 subtract 370, that's minus 120. That's minus 120 plus 4s. You could subtract them either way around, by the way, it won't make a difference. 1000 minus 520 is 480, so we get 480 minus 16s. Now I want that vector, the red one, I want it to be perpendicular to the direction vector, and the direction vector is 1, 4, minus 16. We can see it here, and it was also told to us in the question. So I know that minus 31 plus s, minus 120 plus 4s, and 480 minus 16s dotted with 1, 4 minus 16 is equal to 0. Now, if you're in time constraints, I probably wouldn't write this. This would be a slow way of doing this. I think, because we are further mathematicians, we don't need to write that line out. I think we can just go direct into doing the multiplication, okay? I think we can go direct into doing it. So I have 1, 4 lots of it. That would be a minus 480 plus 16s. I'll do 480 multiplied by minus 16. That's minus 7680. Minus 16 times minus 16 is 256s. I hate s's. That's the only thing. Gavin used an s in this, and I hate s's, but an examiner might do it. So it was a good choice, really, wasn't it? 256 plus 16 plus 1, that's 273s. On the other side, the 7680, the 480, and the 31, that is 8191. So s is 8191 divided by 273. In other words, 30.003663 recurring here. Now, this is an interesting one that's not being asked about by Gavin here. What is the significance of this 30 that we have got? What does that actually mean in the context of this question? Where have I made a mistake? Oh my god. 45. Where's the 45? I don't think I made a mistake, did I? Nah. The wrong value of s. Oh my god, have I done something really ridiculous? 4 times 4, 16 times 16, 256, 16 and 1, 273. I don't think I've made a mistake. It's 4s. This is why this is an s. This is not 45. This is what I'm saying. We've got to make our s's look really different. 4s, not 45. This is how I would write 45. Oh my gosh, you got me so stressed right here. So I was saying what this s represents. This represents the time. It actually is representing the time when she is closest to the drone. So the time when she is closest to the drone is 40 seconds after she left the helicopter, after she jumped out of the helicopter. 40 seconds. Obviously, there was the 10 seconds before, and then this s is not the shortest distance between them. S is the time with it, okay? Is the calculator wrong? 8191 divided by 273. 30.00. Yes, there's an extra O in here. 30.00663663. Now, where am I going to substitute the s? Am I going to substitute it into the green, the yellow, or somewhere else? Where am I going to substitute the S? To the green or to the yellow? The yellow. The yellow is the vector between them. So I will then say the vector between, I'll substitute it into that yellow part. It will be minus 31 plus that S. So I should do that, minus 31. That's minus 0.996336 recurring. So that was 8191 over 273. Okay, then I'm going to do that times by 4 minus 120. We get 0.014652. Have I done that right? 8191 divided by 273 times 4 minus 120. Good. So 8191 divided by 273 times it by minus 16 plus 480. And we get minus 0.058608. So that is the vector between. So the shortest distance will be the Pythagoras of this. The shortest distance is going to be 0.99 part squared, 0.014 part squared, and the 0.0586 part all squared and square rooted. I'm going to type in the longer parts in the calculator. I just couldn't be bothered to write them all out. So that squared plus 0.996336 squared plus 0.014652 squared, square root the answer, and we get 0.998 to 3 significant figures. They would probably give you a range of things that would be accepted for this that we've got here. So we do come to it being very, very close. In other words, it is roughly 1 meter between the woman and the drone. You don't need to write that down. That's just me writing it for the context of this question. And then part D says, by considering your answer to part C, evaluate the suitability of modelling the skydiver as a particle. So I'd like to know what you guys think for this. What's the issue of modelling the skydiver as a particle? Of modelling the skydiver as a particle. Yeah, so she's got dimensions, right? She's got dimensions, so she's probably going to hit the drone, okay? So the problem is, the skydiver has dimensions. The skydiver's dimensions have been ignored. It is likely she will collide with the drone as the shortest distance is very close. Or something like that. You know, this isn't an official exam question, so we're not sure exactly what kind of thing we're going to be expecting for this. But basically, if this is actually what happened, she's going to crash. So there's plenty of things we could criticize about this, okay? We haven't asked for all of the critiques that we've got here. But other things is she would not be moving at a constant velocity. She wouldn't be moving at that constant velocity. She also will not be moving at this constant velocity at this stage. There's plenty of other things we can criticize about this question. Also, she's probably going to be hitting the floor at pretty fast, at minus 16 meters per second. I don't know if this woman's going to make it. I actually don't know if this woman's going to make it. So, that was question 5. What did you guys think of that one? I think that was a really smart question. I really liked the way that Gavin had designed this one. This poor woman might not have got it. Oh yeah, you could say the parachute and the drone might have hit as well. Yeah, good that she wouldn't instantly decelerate to that new speed when the parachute came up. That's a really, really good one as well. I love this. Yeah, I think it was an interesting question. I can't believe, Gavin, you've like just turned 18 as well, right? I think you just turned 18. Like, very, very impressed. He sent me a full further maths paper that he'd written that he wanted me to go through in a live stream, but it was like, it was tough. He'd sold it to me as like a very, very tough further maths paper, and he was absolutely right that we've got here. He hasn't used ChatGPT for this. I know he hasn't, because we've had good long conversations about them, and I told him at the very beginning, no AI please for this kind of stuff. You can just tell it's not AI in the way that he's phrased things at all. I've also had a meeting with him. I've spoken to him face to face. So, okay, we are going to do 2 more questions. By the way, if you like the way that I teach things, I know I've said this before. I'm doing a session at the weekend, £15, 3-hour session plus what, an hour and a half video afterwards. I believe it's money well spent to get some good revision in for the next core pure paper. If you don't want to come to it, who cares? You've got plenty of maths that you can get from me on my channel for core pure, completely for free. I just try and do this to make a bit of money to sort of sustain myself over the year, but really because I think what I can offer in those sessions is really, really good. Oh no, I wanted to do something. I wanted before the session to ignore this and to say what to do for this. So when I say face-to-face for the meeting, just on Zoom. Just in a Zoom meeting. Okay. So yeah, the annotated version of this will come afterwards. I wanted to ask you what the substitution should be for this question, but you've probably seen it already. I think you probably would have known that we would have said that the substitution should either be u is equal to x squared plus 1, or you could say that u squared is x plus 1. Either of those 2 substitutions would probably work quite nicely for this. But we're going to start off by using substitution to do this particular integral that we've got here. And we're going to see how that flows into the next part of this as well. Yeah, this is Gavin's question that we've got. So for part A that we have, whoa, my thing just went crazy. The thing that we are integrating is between 0 and 1, x cubed over the square root of x squared plus 1 dx. The substitution is u equals x squared plus 1. So the denominator is going to be really easy, right? U to the power of a half is going to be the square root of x squared plus 1. If I do some differentiation, du by dx is going to be 2x. So du is 2x dx. So I'm trying to find out what dx is. So du over 2x is going to be equal to dx. I guess we could find out what x is. You might not need to do it. It can tidy up in quite a nice way that we've got. But I'm going to do it with like the full substitution. But sometimes you don't even need to do this kind of thing, okay? I wouldn't use for this question a trig kind of one. We don't need to use a trig kind of one for this, okay? If you do, it kind of does work, but it just gets really a lot more complex than just doing a normal kind of substitution for this question. So if I rearrange this, I'll get that u minus 1 is x squared. So u minus 1 to the half is x. So now I know that du over u minus 1 to the half is dx. I think we've got most of the stuff. I don't think I've done this. So let's figure out what x cubed is going to be. X cubed will be u minus 1 to the 3 over 2. You may not have needed to do this because this x cubed is going to cancel with something with this part, but I am doing it that way, okay? And then for the limits, I'll do the top limit. When x is equal to 1, u would be 1 squared plus 1, which is 2. And when x is 0, u would be 0 squared plus 1, which is 1. So I think we've got all of the information. Between 0 and 1 of x cubed over the square root of x squared plus 1 dx, the 0 is a 1, and the 1 becomes a 2. The x cubed, which is going to be this, is here. This part is this, and the dx is this. So x cubed. You don't need to, you may do it in a slightly different way to me. It's totally fine. That is going to multiply by du over u minus 1 to the half. And that's it, okay? So let's do some simplifying. I think that we can simplify this and this by dividing them. So 3 over 2 minus 1 over 2 is 2 over 2, or just 1. So actually that power is going to become, between 1 and 2, it's just u minus 1 to the power of 1 over u to the half du. Well, I don't need the bracket, do I then? What's going to be my technique for integrating that thing I've just looped? What's going to be my technique for integrating this? This is definitely an A-level question that we've got here. Let's get some more water. Where did the 2 go? Oh my god, where did the 2 go? Where did the 2 go? I would have got this wrong. There's a 2 here. There should be a 2 here, which means there should be a 2 here, which means there should be a 2 here. Very annoying. That's my first proper mistake of this. We are going to split this up into 2 things. So we have, the 2 is in the denominator, so it's going to be a half. U to the power of 1 and u to the power of a half is just u to the power of a half. And then we have a minus a half, u to the power of minus a half. Add in a blank page, and that's just normal integration, right? So I will increase the power to 3 over 2, and I will multiply by the reciprocal, which is 2 over 3. So it's going to be a third for that. Okay, it's a third. This you can check. A third times 3 over 2 is a half, which is what we wanted. And then here I'll increase the power, and that's it. I think that's all that we need for that, because when you pull the power down, you do get the half that goes with it. And that's between 1 and 2. So this is a third, 2 to the 3 over 2, minus 2 to the half, minus a third minus 1. I don't know if the calculator can handle 2 to the 3 over 2. It can't. So we're going to just do that slowly. 2 to the power of 3 over 2. That's 2 to the power of a half cubed. That's the square root of 2 cubed. That's root 2 times root 2 times root 2. That's 2 root 2. Okay, that's 2 root 2. So this is a third multiplied by 2 root 2 minus root 2 minus a third plus 1. So a third root 2 minus root 2, that's minus 2 thirds root 2 plus 2 thirds. Have I done this right? I think so. Common denominator. I don't know if I have done this. I feel like I've made a mistake for this. So I have, with the common denominator, I have 2 minus 2 root 2 over 3. Oh no, it's just swapping them around. It's this minus this. So 2 minus 2 root 2 over 3. No, I've done something wrong. Can somebody spot where I have made a mistake? Something's wrong. A third times that minus a third. 2 to the power of 3 over 2, 2 to the power of a half. It should be minus a third root 2. Yeah, it should be minus a third root 2. Should it? Let's have a look. 2 thirds minus 1 is minus. So I've just literally done something really dumb. Yeah. This is 2 thirds minus root 2. Yeah, let's just quickly fix that because I've made a mess of this. So this is 2 thirds root 2 minus root 2. And then this is 2 thirds. So it's root 2, 2 thirds minus 1 plus 2 thirds. 2 thirds minus 1, oh my god, is minus a third. So it's this minus root 2 over 3. Thank you, guys. Thank you for saving me there. So we know we've got this right as well, okay? So it's 2 minus root 2 over 3. Okay, let's see how this comes up now in the next part of the question. So figure 1 shows the curve C, which is defined by this equation. Y equals x the square root of r shine x, with x between 0 and 1. A local jeweler manufactures and sells gold earrings. A single earring can be modelled by a solid of revolution of curve C 2 pi radians about the x-axis, with its volume being measured in centimetres cubed. The jeweler purchases gold from a supplier who sells 1 centimetres cubed of gold. This is actually the rough price of what gold should be, by the way, for 1 centimetres cubed. I checked it earlier and I was like, this is amazing. Even got a good price for gold. By using your answer to part A, use the model to find the cost in pounds of manufacturing a pair of earrings, giving your answer to the nearest integer. So we're just going to find out how much it costs for the gold for a pair of earrings. He's been very kind and decided to put this in bold. We need to do volumes of revolution between 0 and 1. And it's going about the x-axis, so it will be all the way down here. We're nearly on the last question. It is going to be pi y squared dx between 0 and 1. And y squared is going to be this thing squared. So it's going to be x squared r sine x. Okay, x squared r sine x. X squared r sine x dx. Now, what do you think is going to be the technique for us to integrate x squared r sine x for this? And this might not be something that you know about, so it's something I'll be able to tell you for this as well. It is integration by parts. It is integration by parts, okay? Now, you may not know this. When you do integration by parts, there is like an order of priorities. It is liate, okay? You know that if there's logs, that takes priority for you. The I stands for inverse. A is algebraic, T is trig, and E is exponential. So this thing that we've got, the x squared is algebraic. This, which one is it? Is it L, I, A, T, or E? Which one of these ones is it? It is. There's always a little delay, so I can... Yeah, it's the inverse part, right? It's the inverse. So that means this part needs to be the U, and this part needs to be the V dash. Sometimes people aren't aware of this. So I will do my integration by parts over here. I'm still going old school with this rather than doing the DI method. So U is r sine x, V dash is x squared. I will integrate the V to get a third x cubed. It's in the formula booklet. The derivative of r sine x, it's in the formula book, is the square root of, is it that? The derivative of r sine x is 1 over 1 plus x squared. It is the square root of, they write it as 1 plus x squared like this. Okay, so we know we've already got that branch. We're going to get these two, subtract these two. So it's going to be pi, those two multiplied, which is a third x cubed r sine x, minus these two multiplied, the integral of, minus the integral of a third x cubed times by 1 over 1 plus x squared dx, and obviously the limits are going to be 0 and 1. So that's a pi 1/3 x cubed r sine x. I'm going to take the third out to the front, and I have x cubed over 1 plus x squared dx. And now we know why Gavin wanted us at the very beginning to do this, because we've got it here. Let's write it the way that it was originally presented to us, and that's between 0 and 1. So I've actually worked out, I know what that thing is, because this came up in part A. So to finish, we have pi. I'm going to put the limits now around the first part. That's a third x cubed r sine x between 0 and 1. And we're going to be subtracting a third of what we calculated earlier, which was this, the 2 minus root 2 over 3. Why is my iPad not responding properly? There we go. 2 minus root 2 over 3. So, subbing in 1, we get a third r sine 1. And then we're going to be subtracting 2 minus root 2 over 9. It doesn't ask for exact values, right? It's not asking for exact values, so I'm not going to do an exact value for this question. If you wanted to, you could do logarithms with this, but it didn't ask for that. It's asking for the cost. It's asking for the volume. So I shall do, on my calculator, or I can find it hard to find, but I shall do the inverse sine of 1, divide that by 3, and I will minus 2 minus root 2 over 9. I will times that by pi, and we get that it's 0.71849 centimeters cubed per earring. So the cost for a pair is going to be 0.71849 ... There's two of them. And the gold costs £2,087. £2,087 and 70 pence. So I'm going to times it by 2. I'll times it by £2,087 and 70 pence, excuse me, and we get 3,000 like this. So I loved this question because when I did this the first time, I was like, oh, so that's why Gavin picked the price, because he knew that 2 earrings would cost pretty much exactly £3,000 for this. Gold, that's how much gold costs. If you want these solid gold earrings, they'd probably be quite heavy. £3,000, people with too much money. People of too much money. So I just love the way that Gavin created this flow in this question. The first time he sent it to me, he did not give me a substitution. He said, by using a suitable substitution, show that this thing was true. I was debating, should we include it, should we not? I think because it's the night before, I didn't want it to be too freaky, too like crazy stuff that we've got. So I think it was a good question. I'm feeling quite sad now because we are on to the last question that we've got. And this, I loved this question. I have never seen a question like this because there is an extra unknown in the question, which I thought was really, really smart. I'm just going to take a little pause and to tell you that there is some questions. Okay, I'm just going to put something in the chat. There is something called a Slido. If you want to go through there in a bit, you can have a look and vote up some questions. I'm probably going to answer like the top 10 questions that people have upvoted in the Slido. If you've been in any of my sessions, you know what those things are like. I kind of forgot to mention that as we're going. I'm also going to do a quick little check and see how many votes that we've had. 1,932 votes. 38% of people are feeling terrified. The answers for the questions will just be, there aren't mark schemes. This is the mark scheme. Gavin wrote the questions, doesn't have an official mark scheme. Cool. Well, at the end, I'm going to try and calm the 38% of people who are terrified. Okay. A truck's suspension system is modelled as a mass spring system. The vertical displacement, y meters, of the truck above its equilibrium position at time t seconds is modelled by the differential equation. The second derivative of y with respect to time plus 4y is omega cos 4t, where omega is a positive constant. Initially, the truck is at rest and is at its equilibrium position. At t equals pi over 4, the vertical velocity of the truck is minus 0.5 meters per second. Find a general solution for the differential equation, giving your answer in terms of omega. Okay, I'm going to really quickly decode this. I don't know if we need this yet, but let's do a bit of decoding. Initially, so in other words, initially, the truck is at rest and at its equilibrium position. So if it's at its equilibrium position, y is the displacement. But what would rest look like? What would rest be for this? Good, Sebastian. I hope people will have a look at your locked-in app. I really liked what I saw with that kind of thing. And plus you have a great name as well. I appreciate the super chat for this as well. Yeah, dy by dt it's going to be. So we know from that first statement that dy by dt is the velocity. And then we're also told that when t is equal to pi over 4, the vertical velocity is minus 0.5. In other words, it's moving downwards. So dy by dt, I don't know if I'm going to need that yet, is minus 0.5. I talked to you about neatness, and then I write stuff like that. How embarrassing. Okay, general solution. Write this down. So we have the second derivative of y with respect to time plus 4y equals omega cos 4t. So we're going to have to do, can you tell me what the letters are going to be for this? You know, what are the different stages? I'd love to see all of the letters, those pairs of letters. If I tell you what one of them is, it's going to kind of give away the whole thing. You could write y dot. Y dot just means it's been differentiated with respect to time twice, so you could write it like this as well. Good. We have AE. We're going to do the auxiliary equation first. We're then going to be doing the complementary function, the particular integral, then the general solution, and then we'll have the particular solution in part B. So the auxiliary equation is going to be y squared, no it's not, it's going to be m squared plus 4. There is no dy by dt, that is not there. That's why it's not plus 4m. There is no m, because there's no dy by dt. There's only a y term. So m squared is minus 4. So m is plus or minus, oh my god, plus or minus 2i. I'm not going to ask you to write this down, because, to type it into the chat. It's too long for you to type in. This means that the complementary function is going to be y in terms of t. I tend to use p and q here. You could use a and b, whatever it is you want to use. I'm going to use p and q. I don't know why, I always do. It's p cos 2t plus q sine 2t. We are then going to do the particular integral, and this is where we look at what's on this side. It is a trig function. We need to do the most general one that we've got, okay? So I'm going to now write down the most general form for the particular integral. You can do it with lambda and mu, you can do it with p and q. If you've not used p and q, you could do it with a and b, whatever you want. I am going to be using y equals, I could do capital A, lowercase a. I'm going to just go with a cos 4t plus b sine 4t. I'm going to differentiate it and substitute it into here. I'll make it equal this thing, and I'm going to try and find out what everything is. So when I differentiate, cos goes to minus sine, so you get minus 4a sine 4t. Sine goes to cos, so that's 4b cos 4t. But there isn't any dy dt, so there's a second derivative. So with the second derivative that we've got for this, we're going to do the second derivative. 4 times that, so it's going to be minus 16a cos 4t. And then cos goes to minus sine, so it's going to be minus 16b sine 4t. So this thing is going to sub in here. This thing is going to sub in here. And we make it equal omega cos 4t. And we're going to try and find out what a and b are equal to for this. So minus 16a cos 4t minus 16b sine 4t plus 4 lots of y. I'm going to immediately multiply it by 4. I'm not going to use brackets because it's a waste of time. 4a cos 4t plus 4b sine 4t is equal to omega cos 4t. I know that's gone behind my camera a bit. We're going to need an extra page. So if I collect the coses together, there's a cos here and a cos here. So that's minus 12a cos 4t minus 12b sine 4t is equal to omega cos 4t. So doing like the comparative stuff, that tells me that minus 12a is equal to omega, and so a is minus omega over 12. And because there's no sign on the right hand side, this just must mean that b is equal to 0, okay? So we've now got the value of a, the value of b. I think we're ready to put this all together and to come up with the general solution. This is where we put together the complementary function, which is up here, with the particular integral, which is here, with our value of a and b that we've got for this. So it is going to be p cos 2t plus q sine 2t, and then a is minus omega over 12 cos 4t. B is 0, so there's nothing there for this. So that's the general solution in terms of omega. Then part B says find the particular solution showing that omega is 3. So we actually need to find out what omega is in this question. We're going to find the particular solution. Now, this is where we're going to be using these things that we wrote down here. So I wonder if I can do this. Does this work on GoodNotes still? Yeah, I can copy that. And then I can just paste it here. And I'm going to use some of that information with this general solution. Okay, so I think I'll probably just use this one to start off with, okay? So let's take that. I'll put it over here for now. When t is equal to 0, y is equal to 0. So 0 equals, well, when t is 0, that part's going to go. When cos of 0 is p, and you get minus omega over 12. So p is equal to omega over 12. Okay. I think I need to use this other fact, that dy dt is equal to 0. So I'm going to differentiate this as well. So dy dt, cos will differentiate to minus sine. So it would be minus 2p sine 2t. Sine goes to cos, so that's 2q cos 2t. And cos goes to minus sine, so it's going to become a plus 4 omega over 12, 4 omega over 12 sine 4t, but 4 over 12 is the same as omega over 3. And we know that this thing is true, so dy dt is 0 when t is 0. So when t is 0, that's 0 and that is 0. So we get that 2q, in other words, q is equal to 0. So I've got what p and q are. I now need to use this extra fact that we've got here. So I know from this equation that dy dt, I actually can ignore that part because I now know that cos is 0. It's minus 2p sine 2t plus omega over 3 sine 4t. So when t is equal to pi over 4, we get minus 0.5 is minus 2p sine of pi over 2. I've doubled this value of t that we've got here. And then we have, for the last part, omega over 3 sine of pi. And you need to know that the sine of pi is 0. So we have this sine of pi over 2 is 1. Sine of pi is 0. So we get that minus 0.5 is equal to minus 2p. Remember, that's 1 and that is 0. This is where memorizing those things is really important. 0.5 divided by 2 is a quarter. So p is a quarter. So we actually now can find out what omega is, right? Or maybe we've got the whole bit, because I think we know what p is, we know what q is. We need to know what omega over 12 is. Well, that's p, right? So omega over 12. If p is omega over 12, I think it's just going to be a quarter, right? Yeah, because omega over 12 is p. So that last part is going to be a quarter. But we needed to show that omega was 3, didn't we? We needed to show that omega was 3. Of course. So I'm going to use this thing here. P is a quarter, and that's omega over 12. 12 over 4 is omega. Hence, we've shown omega is equal to 3. Another page. This means that the particular solution is y equals p cos 2t. Well, p is a quarter, so it's a quarter cos 2t. And then we have omega over 12, 3 over 12, which is minus a quarter cos 4t. I haven't seen the chat for ages. Are we doing okay? How are we doing, guys? We're doing all right. Okay. We are on the last part of this. We now have part C. Using your answer from part B, find the minimum vertical displacement when t is between 1 and 2. You know what we need to do for this, right? Minimum is going to be solving this. We've differentiated this so many times. I'm probably going to differentiate it one more time because I'm trying to find a minimum. Cos goes to minus sine, times it by 2. Cos goes to minus sine, times it by 4. Like this. Minimum, so I'm going to solve this. What do I need to do, guys? We're nearly here. What do I need to do to finish by solving this? You're right, these questions are so tiring. These questions are really tiring. There's so much that needs to go on in this. Yep, we are going to do the double angle formula. I'll put it on this side, so we have, I'll leave it here. So if I do this part first, it will be 2 sine 2t cos 2t minus a half sine 2t. I'll factorise out the sine 2t, so that's 2 cos 2t minus a half. So either sine 2t is equal to 0, or 2 cos 2t is a half. In other words, cos 2t is equal to minus a quarter. So our final thing is to solve these and see which is the one that gives a minimum, okay? So inverse sine of 0 gives us 0 pi or 2 pi. So we have either 0, pi over 2 or pi. But remember in this question, I don't know if you remember seeing this, Gavin told us that t was between 1 and 2. So because t is between 1 and 2, I won't use this and I won't use this. We can solve this other one and see what we get. So I should do the inverse cos, obviously in radians mode, the inverse cos of a quarter. We get that 2t is 1.318 and also 2 pi minus the answer, which is 4.965. When you half them, you get 2.48 something, and you get 0.659. Both of these are outside of the range. They're not between 1 and 2, which means this one must be the answer because that is inside the range. So t is equal to pi over 2. Pi over 2 is like 1.5 something, so it is between 1 and 2. If you wanted to, and it didn't have that range between 1 and 2, you would have to check which of these ones give you a minimum and which ones don't, okay? The final thing is actually to find the minimum vertical displacement. So you do need to find out what y is equal to when t is equal to pi over 2. So the final thing is to find y, and it is a quarter cos 2t, a quarter cos 2t minus a quarter cos 4t. Cos of pi is minus 1. Cos of 2 pi is 1. Minus a quarter, it is minus 0.5. So the minimum displacement is 0.5 meters below the start point. I know it's behind the camera, I'm going to move it. And I think I've done this on Desmos if my iPad has remembered. It has. So I've got the curve drawn, and we can see that between 1 and 2, there is that minimum point when pi over 2 is the time, the displacement is 0.5. And these were the other ones. These were the other turning points. Or not that one. I don't want that one there that we had in the question. The 0.659 and the 2.48. The 0.659 and the 2.48 that were there. That's it. So we have got about 10 minutes left. I loved that question. I want to say a huge thank you. I know I've said lots of special thank yous to Gavin, but really I've just been so impressed with what he's done. So Gavin, thank you so much. And Gavin's going to be doing some other questions for some of my future live streams as well. I haven't done a complex series question. I do a whole section on complex series in my Aiming for a Star session, okay? So I'm going to switch back to the big camera so I can see you all, which is a stupid thing to say. I can't see you at all, but you can then see me. Can we all just big up Gavin in the chat for a second while I go and have a quick look at these questions that have been submitted? I think Gavin deserves some bigging up, to be honest. Okay. So I'm going to have a look at some of the questions that have been asked, but I'm not going to be accepting any more questions that we've got on here, okay? We are going to have a look at just probably the top 10 questions that we've got, and I'll try and answer some of these things. But I want to check back and see. Yeah, everybody's giving Gavin so much love. Everyone's giving Gavin so much love that we've got. And I like that people have... yeah, this is so nice. I think there's quite a bit of a delay now. Is there? If I put my hand up, I can see how long the delay is. Then I'm going to start going through those questions. Yeah, there's a bit of a delay. It's not the end of the world. I'm going to start answering the questions that we've got. I'll stick around here until 7 o'clock and we will go from there. Okay, so the questions I'm going to answer. The first one, the most popular question, was how should we go about questions that rely on parts of other ones if we don't get the first part? For example, if it says using your answer to part A. I hate it when they do that, especially when in part A, they say show that it's equal to this thing, but there's like an unknown that's in there. I really, really hate it when they do that kind of stuff. I find that very, very frustrating. So if they do that, just guess a value for the thing that you don't have, for the A or the B or something. Guess that value and just proceed with the question so you can get all of the method marks that you have there. That's definitely something that I would want you to try and do, okay? The second question, I've seen everything you need to memorize videos, but are there any lesser known facts or methods for topics that students often forget which could be useful for Core Pure 1? If there's a particular topic that you want, like the latest, what is the thing that Mr. Bicen would say about this particular topic? If you go to my chapter summaries, go and have a look at the chapter summaries. Those videos that I have made have my like freshest, most up-to-date opinions on the things that you need to memorize. Obviously, there's quite a lot of them, so you won't be able to watch all of them, but I would kind of focus on the particular ones that you're going to, that you want some help with, okay? Do I think this year's paper is going to be hard compared to other years? My instinct, obviously I don't know until we all get into that exam hall, my instinct is that this is going to feel very similar to 2024 and 2025. Questions that are doable, a couple of spicy questions, but high grade boundaries. They seem to be quite into having high grade boundaries, which means the papers are easier, they are more accessible. So that's the kind of stuff I'm anticipating. If I went into the exam hall tomorrow, because I'm going to go into the exam hall, do it, leave my answers blank at the end, and I see a question paper that's like 2023, I'm going to be shocked. I don't think they want to do an evil paper. They've stopped doing that recently. So we're soon going to see what happens. The next question is, how do we prepare for really difficult questions like the ones that came up in 2023? Okay, so this is going to be a bit more broad advice for this. I'm going to say two things. One of the things about preparing for it is you need to have been looking at tough questions across the whole time that you've been studying to be good at it. Yeah, it's the night before. We've looked at some tough questions. I want to talk to you now about my second broad reason for this, is about being sort of like the psychology of what happens when you see a hard question. You will have heard me say this plenty of times before, but you need to remember that everybody in the exam hall, everybody across the country looking at that, including me, will be like, whoa, this question is crazy, this question is really stressful. And you have a choice. You can either choose to stay calm and think, how can I relate this to things that I know? How can I get, in a 5-mark question, how can I get 3 of these 5 marks? How can I get 4 of them? How can I get 2 of them if you can't do anything? The other choice you have is to just give up and say, I can't do this. I'm going to get 0 out of 5 and I'm going to move on. I think I know what the better answer of those two things is, and I think you know what the better answer of it is as well. Remember, when something is tough, look around the room very, very briefly, and you'll suddenly be like, everyone else finds this question hard too. The examiner has designed it in this way to make it stressful. I'm not going to let it intimidate me too much. I'm going to do as much as I can. I'm not going to let it waste my time, and then I'll move on to the next question. So that's what I would say for tough questions like this. And that's the next question that's there as well. I like this question. Do I have any tips for the morning of the exam? Should we be doing much revision if our exam is in the afternoon? If so, what would be the most efficient? You need to decide what is right for you, but I do have an opinion on this. My opinion on this is that the morning before an exam is quite like a sacred kind of time, right? If you were going to be running a marathon in the afternoon, you wouldn't be practicing by doing sprints or running or like getting yourself really tired. If you were running a marathon in the afternoon, you would be doing things to keep yourself relaxed. You'd be eating well, you would be trying to stay calm. You might do a few things like before the marathon being like, oh yeah, what were the times I was aiming for, or what pace am I trying to set? You might have some of those strategic conversations with yourself. You might have like flashcards that you'd look at, not for a marathon, but for a maths exam, to be like, yeah, I'm just going to make sure I've remembered these things. That's my personal belief of what I would like you to do. That's pretty much, I mean, that's for students who have done a lot of revision. If you haven't done enough revision, I don't really want you to be cramming. I still want you to have that time to be calm, because if you are exhausted and you stay up late and you have caffeine and you do things that you don't typically do when you're preparing for an exam, you will not perform to your best ability. Okay? You can do a few things now to improve things by being here in this live stream, seeing some stuff like this, but I don't want people to really stress themselves out. So please, please be calm and look after yourself in the mornings. I find that I keep making silly mistakes. If I go slowly and to be more careful, I keep running out of time. I'm also not sure why this is happening, and you made even more than you usually do, so do you have any tips? Depends on what type of silly mistake it is. If you know, oh, the kind of silly mistake I always make is this thing, just be really mindful of that at the beginning of the exam and think, I always copy the values down wrong. I'm going to make sure I check all of the values that I write down. I'm going to check them and see that I've written them down correctly. That's my most common mistake. I'll do a vectors question and I will have copied the values down wrong. Like in the helicopter question, I get it wrong because I didn't even write it down properly. So I now try and check those things as I'm going. I also think, to the person who asked that question, I think there's a lot of psychology to this as well. Don't go too slowly, because if you go too slowly, you then get in a panic for the second part of the exam as well. Silly mistakes, listen, every single person apart from anyone who gets full marks, everybody's going to make a silly mistake. So don't be too harsh on yourself, just try and minimize them as much as you can. The liquids in a tanks question, I actually do a whole section of that in my aiming for A-star session, which is one that you can get immediately. The recording will come through to you in the inbox. You can get that. So that might be something I'd recommend. I'm not going to spend much time doing it now because I've only got like a couple of minutes left. What's the best way to spot when to use integration by substitution when the question doesn't tell you? Most of the times it would tell you, but it's substitutions when you can't seem to do integration by parts, you can't do reverse chain rule, you can't do partial fractions. It's quite rare for a question to have to be integration by substitution if they don't tell you it. The in and out rate questions I think I've just talked about. Simple harmonic motion and damping seems to be something that hasn't been asked about very much. My theory for that is that it gets asked about a lot more in further mechanics. So that's why I'm thinking it doesn't get asked about. We haven't really seen any past paper questions on it at all. We talked about silly mistakes. Predicted papers, if anybody is giving you a predicted paper before tonight, they're lying. It is not possible to have a predicted paper before Corpio 1. It is not possible. However, in between Corpio 1 and Corpio 2, we can have a good idea of what topics are going to come. We can't predict the questions, but we can prepare ourselves for those topics really well. Top 3 most likely topics to come up. Okay, this is now not, I have no authority on this at all, but what I think will be there tomorrow, there is nearly always complex numbers in both papers. So I think there's going to be some type of complex numbers, pretty broad thing to say, usually some kind of roots of polynomial. I think they probably will have a matrices question, maybe some kind of like linear transformations or matrices tomorrow. And I will also be expecting to see vectors. So I tend to think those things will come up, probably approved by induction tomorrow. But remember, if it doesn't come up in paper 1, I think it's going to be there in paper 2, most likely as well. Okay, I'm going to just answer one more question that we've got here. 2 more questions. Someone said, what should we do in the week between Corpio 1 and Corpio 2 to prepare for the second paper? I've mentioned this several times. There is a link in the description. Get a recording of or come to my in-between Corpio 1 and Corpio 2 session for £15. I will prepare you on as many topics as I can and show you some tough questions that will be really, really good for your revision, plus the video that comes with it afterwards. And the last question that I'm going to answer is, any tips for managing time pressure? Yes. Sometimes people go into the exam hall and they're like, this question's really nice. Question 1's really good. I'm just going to take my time and I'm going to be nice and slow. I'm going to be really careful and really accurate. And then they get to question 6 and they're like, oh my God, I've got 20 minutes left and I've got so much to do. And they just get into a blind panic. So when you get in there, yes, it's okay to be a bit calm at the beginning, but I want you to start with like a sprint start. You're like, I'm going to do this accurately. I'm going to be accurate. I'm going to be fast. Don't make mistakes. But you're going to go in there with question 1 with that same, okay, cool, I'm going to go as quick as I can. I'm going to try and keep as focused as I can. Obviously, if that starts getting you stressed, don't do that. But just remember there is that pressure at the beginning of keeping up with getting it to a good pace, okay? So what I always like to do at the end of these things is to just give you a bit of a cheesy pep talk to think about exams in general. Now, I do want to start off by saying, I know these exams feel like the most important thing to you right now because it's the only thing your friends can talk about. It's probably the only things your family will ask you about. How's your revision going? Have you had your first exam? How's it going? In the grand scheme of things, it really is not the most important thing. If you have a bad exam tomorrow, the best thing you can do, my advice is always when students have a bad exam, I'm always like, go home, watch a film, get a nice takeaway, do something to just treat yourself, like have a nice, like whatever you do to relax. But then when you wake up the next day, you just move on. You just say, I had a bad exam, but you know what, for further maths, I've got 3 more and I'm going to do really, really well in those other ones. And I think that idea of being able to kind of like leave some stuff behind is really important. The second thing that I want to say is when you come out of the exam hall tomorrow, some people will have had a really good experience. Some people might not have had a good experience. And you should care for anyone that's been in that exam hall, whether they're your friend or not your friend. Don't do that thing where you go around and you say, what did you get for question this? What did you get for question this? Oh, I got this. Oh, this was easy. Oh, I found that easy. It's just not necessary. And it might make you feel better for like 5 minutes, but it can make other people feel quite stressed. And I just want you to really be there to kind of like look after each other and make sure that you are being as supportive as possible, okay? You guys have got this. You have been motivated to come along to this live stream. You've been with me for 2 hours, some of you guys. And I feel confident you're going to be in like such a good position, okay? When you come out of that exam hall tomorrow, I will have had on my channel a poll that you can vote to say if it was better than you expected, the same as you expected, or worse than you expected. So you can do that poll. I will also be doing my live reaction, not live reaction, but I will be reacting to the paper as soon as I get out of the exam. I'll go into my car, I'll film a video and tell you what I thought of the paper. And we'll basically go from there, really. And hopefully I'll see some of you on Saturday. Okay, so I will be making that reaction video as well. I wish you so much luck. If it's good, amazing, move on, get ready for the next exam. If it's bad, take stock, look after yourself tomorrow evening, and you've got plenty more opportunities to do really well. They're important. They are not more important than you and feeling happy and not making yourself stressed. And my last tip is, if you feel nervous, so nervous before the exam, try and remind yourself of other times when you felt nervous but you've done really well, whether it's been before a performance, before a sports event, where you have those nerves and those nerves actually feel good. They give you adrenaline in a good kind of way. And someone else said this to me before. Nerves and excitement feel very, very similar to each other. So if you feel nervous, try and say to yourself, actually, I'm just excited to get my first exam done and do as good as I can. That can be a really good way of a mental reset that we've got here, okay? I hope you have enjoyed this live stream. This has been one of my favourite live streams. The quality of responses from people has been incredible. A huge shout out to Ash, who has been moderating and just seeing that everybody's been good. Ash, thank you so much. Ash has been a huge support for me across this year in all of the different events that I do. And I, of course, would like to do another special thank you to Gavin. Thank you so much, Gavin. We will be doing more live streams. I will be doing another live stream the day before Corpio 2, but it won't be as sort of like detailed or as much as that I go through my in-between Corpio 1 and Corpio 2 sessions. And the grade boundaries are going up for me. That's hilarious. That is hilarious. So I guess this is it. Please let me know in the poll tomorrow how it goes, and look out for my reaction video. And fingers crossed it's going to be good. Fingers crossed we have some really nice things. If you have enjoyed this, please just leave this video a like. I want to see how many extra likes I can get just before it wraps up. I think we had 205 likes, so I'll see how many extra you get. And in total, we have had 2,238 votes. I hope, to the 37% of people who said they were terrified, I hope my little pep talk at the end there has been useful, okay? I will be doing a Corpio 2 live stream. It will just be the day before the exam, so you won't have as much time to do all of the extra questions that will be in my one that I have at the weekend. People have said such lovely messages. I'm really happy. Yeah, I know you've already voted for terrified. You could now change it from terrified and put it onto calm and ready. I hope everybody is now feeling calm and ready. Go and do a really nice relaxing evening. You have done an amazing amount of revision right now, so you can go and give yourself a bit of a relax, okay? Yeah, that likes have gone up so much already. That's amazing, you guys. Nearly at 300. We've done it. Whew. Right, guys, I'm going to close this down. Thank you so much for being absolutely brilliant. Wishing you the best of luck. Thank you, Ash. Thank you, Gavin. Thank you, all of you guys. And I'll speak to you soon. Good luck.